Good morning, students. Myself V. Narsimlu, lecturer in physics, SRNK Government Degree College, BANSWADA, Department of Physics. Today, I am going to take the class BSc MPC MPCS second year. The today topic is indicated by thermodynamic potentials and Maxwell equations. Thermodynamic potentials and Maxwell equations. So, what are the thermodynamic potentials or indicates? How we can determine these thermodynamic potentials? Now let us see how to take. What is the thermodynamics? So here, this is the unit second. Okay, thermodynamics means the dynamics which can be used to explain the thermal energy or heat energy is called as the thermodynamics. So what is the thermodynamic potentials? Now let us we have to consider the title of thermodynamic potentials. The thermodynamic potential is nothing but the energy functions such as enthalpy, internal energy, Helmholtz free energy, Gibbs free energy. These are all produces to form a thermodynamic variables such as pressure, volume, temperature and entropy. Okay, these four variables are called thermodynamic potentials. So here let us we have to studied or learn one by one gradually. So what is mean by the internal energy? What is indicates? And next, what is the meaning of enthalpy? How to this enthalpy is used to determine the heat transmission. The third is Gibbs free energy and Helmholtz free energy. So now let us we can take the one by one in this. The first is represented by internal energy. What is the internal energy? The energy which is stored inside of the internal molecules or inside of the molecules of the system is called as internal energy. This can be denoted by capital U. U equal to, we can write Ui minus Uf. Ui is the initial internal energy, Uf is the final internal energy. So therefore, the difference is represented by the internal energy U. But according to first law of thermodynamics, dq equal to du plus dw. What is meant by the first law of thermodynamics? The given small change of the heat energy to the system is equal to the sum of the internal energy and the external work done by the system is called the first law of thermodynamics. So here the dq internal energy, dq heat energy given to the system is right in terms of the entropy is represented by TdS, dq equal to TdS, and external work done by the system is small dw equal to pdv. These values substitute above equation, we will get TdS equal to du plus pdv. So according to this, let us we have to determine the du. Du is equal to, we can write TdS minus pdv. This is the equation 1. This is the change of the small internal energy of this system. Next, second thermodynamic potential is called enthalpy. Enthalpy nothing but that is the very simplest statement. The constant heat energy of the system is called enthalpy, or sum of the internal energy and external work done by the system is called also enthalpy. Enthalpy is denoted by capital H. H equal to U plus PV. So this is a very important formula. According to this, we have to explain or derive the change of the enthalpy of a heat radiated system. So H equal to, what is the formula? U plus PV. So this H equal to U plus PV equation can be used to, we have to derive or differentiate this equation in both sides. We will get the this is the dH is equal to du u plus pv, ante du plus pv is the uv method. That's why, my dear students, pdv we can write plus v dp, similar to the mathematical formula. What is the mathematical formula is there? We can take the, what is the differentiation of the uv method is there, u into dv plus v into du, as like we can differentiate with respect to what is the differentiation of uv. So when we have to write dH equal to, we can obtain the, what is this is but we know already the internal change of the internal du is equal to TdS minus PdV. This is obtained from the internal energy of the system. This value, substitute the above equation, we will get the dH equal to TdS plus, so what is here, we can take the minus of, here du, we can write the TdS minus PdV, du equal to plus PdV plus VdP. So here, minus PdV plus PdV gets cancelled, so remaining is TdS plus VdP is there. Therefore, final equation dH equal to TdS plus VdP. This is the second equation of the enthalpy. Therefore, according to second equation, the change of the enthalpy dH is equivalent to the, what is the TdS plus VdP. So this is the second thermodynamical potential explanation. You got the third thermodynamic potential explanation is represented by the Helmholtz free energy. Helmholtz free energy. What is the Helmholtz free energy? The Helmholtz free energy can be write F is equal to U minus Ts, internal energy minus product of the temperature and entropy. So this is the Helmholtz free energy. Understand here? So therefore, this equation again, similarly, how do we have to differentiate the enthalpy in both sides? Similarly, this equation is differentiating, then we will get the dF equal to du minus TdS minus SDT. But du equal to TdS minus PdV according to internal energy. So this value substitute above equation, we will get the this in the plus TdS minus TdS gets cancelled. Now we will get the dF equal to minus dV minus SDT. This is called third equation. So this third equation is called as the change of the Helmholtz free energy of the system. And next is fourth thermodynamic potential is called Gibbs free energy. It can be denoted by capital G. Therefore, the Gibbs free energy can be defined as the the difference between the enthalpy and the product of the absolute temperature and entropy is called as the Gibbs free energy. So G is equal to H minus Ts. So again, this equation can be differentiated in both sides. We will get the dG equal to dH minus TdS minus SDT is obtained. In that, let us we have to substitute the change of the enthalpy dH. So this purpose, the dH can be obtained from equation 2 to substitute. We will get change of the enthalpy dH is equal to TdS plus VdP. this value to is there, this value substitute in that equation,